In this demonstration, I am going to work through some of the difficulties when creating a console-based application. One of the most tedious things to do in a console-based application is to prompt the user for input, read that input, and then convert it into the data type that you desire. Most of the time, you are not going to just ask for strings, but you will ask the user to type in something that represents an integer or a date time, something that needs further processing beyond what console readline is going to provide. So let's go ahead and take a look at that problem in detail. If we have a standard application here, it's a console application, and I will put in the customary press enter to quit message and a console read line at the end. And I can do all of my work up here. So the first thing you would likely do is say something like console write, please enter your name. And then you would have to create a string, call it name, say console.readline. Then we can do a console.writeLine and say hello, name. Now when we run this, you see please enter your name. I'll put in my name, and it just spits it right back out. There is nothing complicated about this particular example because we are only looking for a string. Now, however, let's say we are looking for something beyond a string, like an int. Again, we'll start with a console write, and we'll say, please enter a number. Then we'll have to have another string here, and we'll call it num. Set it equal to console.readline. Then, after we read in the number, we can assume it is a good number, but that's usually a bad assumption to make. My philosophy is that a user will do whatever is possible to break your application. And if they were to type in an A and you tried to do a standard parse on that A into an int, it is going to fail. So the one method we would try to use then is try parse. And notice here the string is called num, and I have to come up with another variable to represent this number. I'm just going to call it value. And you can already see part of the problem we're facing here is now we have to have multiple variables to monitor or to process this data. So we have an int value, and we'll set it equal to 0. And the reason is we are going to have to do a try parse, and try parse accepts the value we're trying to parse and the variable we are trying to parse it into. And you can see it is an out parameter, which means the try parse method will assign a numeric value to this value variable if it succeeds. If it fails, value isn't touched. So what we need to do then is say, I'll just grab that console write. Actually, I'll make it a write line. And I'll say you entered. And we can use string interpolation here. We'll say value. Else, that's not an int. So let's go ahead and run this again. And we'll enter our name, then we'll enter a number. If we enter 5, you entered 5. That's great. Let's run it again. And we'll put A. That's not an int. Okay, But what happens if we do not want them to be able to get past this block of code without actually entering a valid number? Well, now it gets even trickier because we're going to have to put this in some kind of loop waiting for this value to be valid. So we can do that with a while loop, and then we need to determine what we're going to put into this while loop. Well, since the value is defined in here, I could of course move this variable up above while so I can use it within the parentheses, but it's not going to tell me anything interesting because this value is already a legitimate number. So I would have to actually set this to something out of the range I expect to use this as a sentry. Alternatively, we could put in a Boolean variable, and we'll call it OK, and we'll set it equal to false. And then our while loop will work off that condition. So while not OK, it's going to keep asking us to enter a number. When do I set OK to true? I will set OK to true here. Otherwise, it will remain false. Then I'm allowed to continue. Run it again. Put them in the name. Now this time I'm going to put in an A to start with. That's not an int. Please enter a number. And if I put something too big, it's still not a number. But if I put in a valid number, then it lets me continue. So we are getting to the point where asking the user for a value, a numeric value, is almost 20 lines of code. It gets worse when we have to also check for a range. So let's change this from please enter a number to please enter a number between 1 and 10. So now, if we get a valid number, we have to ask the program or the code one more time whether or not that number is valid within the range we've defined. So if it's here, that means we have a valid number. Then if value is greater than or equal to 1 and value is less than or equal to 10, then we can say that's a valid value. Otherwise, we have yet another else. And then we can, let's use string interpolation here, and we'll say value is outside the acceptable range. Let's run this again. And let's put in a 0. 0 is outside the acceptable range. 11, still outside. Let's do 10. Now it's okay. Okay, so let's take a look at this code here and just say, oh boy, that is quite a lot of code just for asking for an integer value within a specified range. This will get even longer if we also decide we want to add color. So we say console.foreground color is equal to, let's use white for prompts. And then for readline, we'll make it yellow. And then if it's an error, we'll make it red. And if it's valid, we'll make it green. And because we are conscious programmers, what I'm going to do is, not going to do it that way. I'm going to say console dot foreground color here, so we could set it back to the original once we're done with that code. So including the color information, we go from line 18 to line 47. That looks like about 30 lines of code to me, just to prompt the user for an integer value. So we can run it again. And now you can see our colors are taking effect. So we'll do something out of the range. Another one that's not an int. And then we'll do the acceptable value. And you can see the color goes back to the default gray when we're done. It's starting to look better and it's starting to behave better. But if we had to do this every single time we need to prompt the user for a value, and it's going to be similar for all of the different data types like date, time, etc., well, your code is going to blow up significantly. Obviously, one of the better solutions here would be to abstract this into its own method. So to that end, what I can do is right-click, Quick Actions and Refactoring, Extract Method, and here it's called New Method. So that got rid of all the code I needed, but I needed to actually return an int. So instead of New Method, let's call it readInt. And I'm going to take this value and put it outside of our loop because I need to actually return it when it's done. And now I can say int value is equal to readInt. It's going to do the same thing as it did before. And I do get the value back here, but I didn't actually prove it because I didn't output it. But it is getting returned. The point is, now this is a very specific readInt method that is going to look for a value between 1 and 10. And the prompt is always going to be, please enter a number between 1 and 10. So what makes this possibly a better method? Let's pass in some of this information so that we can use it in a more generic form. So we'll have a string here, and we'll call this prompt. And then we'll have an int min and an int max. And these will represent the configurable items of this method. So when I call readInt, instead of saying please enter a number between 1 and 10 always, I'm going to cut that and replace that with prompt. And then I'll go back up to this call. See how readInt is no longer valid? It's because it's expecting 3 values now. So I'll put that as the first value, and then we already know it's going to be 1 and 10 for min and max. So now this call is correct. So this will be, please enter a number between 1 and 10. This is a 1, and now this is a 10. Where do I have to fix things? Well, right here, we're still hard-coded to 1 and 10. So I need to change this to min and max, respectively. And now, right now where it says you have entered or you entered value, I'm just going to comment that out here. And I'll move this here, just to prove we are reading the value and we can output it from the caller. Let's run this again. And we'll give a name. Enter a number between 1 and 10, A, then 5. You entered a 5. Notice it's not green anymore because where I was doing the output here, that's where I was setting it to green. So I can move the green over here if we want it to look the same. As a matter of fact, the only thing we need to do is set OK to true to indicate we are now a valid number. We could also get fancy with this while loop, and we can set int value to something that's invalid, that's outside of any possible range. That's not really possible because we could say min is int min value and max is int max value. But the point is we could, instead of using this Boolean variable here, we could actually put this type of condition inside the while loop as well to minimize the amount of code we're writing here. It is not necessary, but it is something you may want to look into. Okay, why did I bother doing the method if I'm only calling it once? So let's call it a second time. And this time we'll say value, and I can reuse the variable because I'm not really doing anything with it right now. And I'm just going to copy everything, actually. I seem to be having a copy and paste problem here. There we go. Get rid of the int. And now I'm going to ask for a number between 1 and 100. And I can change this 1 to 100. And just to prove that it doesn't have to be 1 every time, we'll say 20 and 100. And remember, it doesn't really matter what's in the string as far as range validation. These values have to be correct. And notice that's all I need to do now to read in a new int with a new valid range. So let's go ahead and run the code one more time. Let's enter A just to prove it still doesn't work. Okay, the first one will enter a 5. Now please enter a number between 20 and 100. Well, let's put in a 5. 5 is outside the acceptable range. Please enter a number between 20 and 100. 101. And let's do 50. And you can see we finally get out. So this encapsulation of the functionality into a method allows us to be very generic in the method, but allow a lot of flexibility when we call it. So we can provide different ranges of values that are valid. We can provide a different prompt. The only change here is the 20 and 100, but you can see it's definitely a different prompt. Let's go ahead and also, instead of just looking for an int, let's do read a more complicated one, date time. And then we can have, instead of a min and max that are int, we can have date times min and max. Then we have to make some subtle changes here, like int value. This now has to be a date time. And we're not going to do an int try parse. We're going to do a date time try parse. And because date times are structs, therefore value types, I don't have to worry about whether or not greater than or equal is going to work on this particular data type, because those operators are defined on the value of the dates. So it will actually be able to compare January 1st to January 3rd. I also should fix this. The value, I need to give it something. I'll just give it min value, just to assign something other than 0. And then, I have to make sure I return a date time. This should be sufficient, other than my obvious typo inside of that string. This should be sufficient for this code to work now as well. So let's go back up to here into the main, and we'll create a new date time variable. I'll just call it dt. And then I am going to assign to it read date time. What is your birthday? And then we have to provide a minimum and maximum date time. Date time.min value, although I doubt I could be 2 billion years old. Let's actually give it a new date time and assume I couldn't have been born before 1900. And for the max, I assume you can't ask anybody what their birthday was if they haven't been born yet. So we can use datetime.now for the upper range. So we're saying between January 1st, 1900 and whatever the current day is. And then we could also change it back to green here. By the way, that prompt is also going to be in green because we don't set it back after this call. And then you entered DT. And we can use a format here if we like. We'd say month, day, I'll just use a single digit, year. And let's go ahead and run it. Enter your name, enter a number, enter another number. What's your birthday? A. That's not a date time. 1. That's not a date time. Let's say 1/2/35. You enter January 2nd, 1935. And we can continue extending these methods from read date time to ask actually for a string. We can prompt them for a specific string. We're not going to parse a value out of it, but we could constrain it to a specific length. That could be important if you're writing data to a database or needs to fall within a specific range for a table, like you don't want it larger than 20 characters. So instead of min and max being of type string, those would be of type int, indicating what's the smallest and what's the largest string that you'll accept. You can also do this for enums, but rather than type it out here, I'd rather show you the class I've provided for you that is available on Blackboard as well, and I call this console helpers. Now I integrated this into a lab. We call it lab 1. I believe this is from C# 2. And that part doesn't matter because it's going to work the same no matter where you utilize this. But console helpers takes what I was just showing you and makes it even more feature rich because it allows you to set the prompt input and error color globally for this particular class. So every time you ask for data from the user, it will set the colors of the text appropriately. So we have a prompt color, an input color, and an error color. And so to set those, you would simply say console helpers dot prompt color equals whatever value that you wish. I automatically set them at the beginning to white, yellow, and red, respectively. And notice it's in a static constructor because this is a static class. So yes, you can create a constructor on a static class that is called the first time you access any members of the class. There's an extra method in here called WriteBorder, and all this is for is printing, in this case, equal signs a given number of times. Since this ch parameter is overwritable, so when you call WriteBorder, you can supply a hyphen, plus, whatever character you want. However, if you don't supply ch and just give it a length, then it is going to print that default character that number of length times. If you don't provide a length either, it'll just be whatever the width of the window is. So as you can see, it also, every time you call one of these methods, it creates an original color so it can remember what to set it back to when it leaves. Everything here is done within a try block, so no matter what happens within the code, it'll always reset the color appropriately. So for the WriteBorder, sets the color to prompt color. It gets the current top cursor top value, which is the y coordinate of the cursor. It sets it to the beginning of that row. It gets length. First of all, if it's not provided, it gets the length based on the width of the current console window. And then it creates a new string of character ch length times, and it outputs it, and then it resets the cursor position back to the beginning of the next row. Here's one of our first read methods. It's called read bool. And read bool is just what you think it does. It allows the user to type in a yes/no type response. You can provide whatever prompt you wish, and it will accept y, yes, true, or 1 as a true value, and any upper or lowercase combination of these. Because as you can see, it takes the input and converts it to lowercase, and then it checks to see what the value is. So y, yes, true, or 1 all respond as a true value. Otherwise, it returns a false. Here's that read string I was talking about, where you can provide a prompt and then a minimum length and a maximum length for the text. Notice here that these are also optional values, so if you do not provide a min length or a max length, it sets those values to 0, in which case there is no minimum or maximum length. But it pretty much does the same thing as any of the other read methods, in that it changes the color. It does have that done sentry. We used OK in our other demo, but it's basically the same thing. And it will repeat this loop until we have a length that is appropriate based on what was given for these parameters. Read char is a simple method for reading a single character. And notice here we can provide an array of what the valid characters are. So if you only want vowels, you can provide an array of vowels like A, E, I, O, and U. And then it will only allow you to put those values in, otherwise it'll keep prompting for input. Read byte will allow you to read a byte from the user. Now notice here we are returning an int rather than a byte, and that is just a formality that I put in place because a lot of the programs that were accepting bytes as returns were not appropriately casting them. So rather than jump through those hoops, it's just being returned as an int at this point. You can feel free to change it back to byte. That is definitely a valid response. Again, it had to do with a specific case I was running into, but that is something you can also adjust yourself. This is how hard it is to fix it. Just type in byte. And now it'll return a byte. So again, it was set to int for a very specific use case on my end. Read int, this is pretty much the same code we had before, just a little beefed up with the colors. It also, like all the other ones, it's in a try block, so if anything goes wrong, it'll at least let the user know something went wrong before it crashes the program, because it's simply going to throw the exception back to the user either way. But notice in here it also does a fancier version of try parse, where it allows leading signs, it allows thousand separators, and it's going to use the current culture information. So in the case of like some European countries, their thousand separator is a decimal point, where in the US it's a comma. So this will use whatever the current culture's format is. Read long should be pretty obvious what that is. It's pretty much just like the read byte and int, except now it's for longs. Decimal, it's for decimal values. Read float, it's for floats, and as you can probably guess what's next is read double. And again, it's basically following the same pattern every time. And then we have our read date, which is the date time version of those methods. And now we finally get to something a little more interesting. Read enum. When you have a list of enum values, and the best way for me to demonstrate this would be to actually call it, but let's just walk through it real quick and so you can see what's going on. First off, you'll see here we're using something called generics. If you're not familiar with generics, it is not important for you to know how they work right now. You just have to know how to call it. So when you call read enum, you have to provide in angle braces the data type of the enum that you wish to constrain the input to. So if I had an enum called days enum, where the enum contains Sunday, Monday, Tuesday, etc., then that's what I would pass here as when I call read enum, it'll be angle brace, and inside there will be my days enum data type. Then we have our standard prompt. Now there is no constraint where I could say t must be an enum value. The best I can do is say it's a value type, and that's what this where t::struct means. This is how you can constrain generic values, such as this t, to be of a specific type. Now, if I could constrain it to a class type, then I could use that class type here instead. So I could say where t::person. So then t would have to be a person or something that is of type person. Okay, so let's move on. And you'll see I create a data type of type t. That's what the type of command does. It basically allows you to take like int or date time, or in this case, the generic type t, and convert it into a formal type. So this is starting to work into the reflection side of C#. And then I create a value of type t and set it to the default value of that data type. For numeric values, such as an enum, the default value is typically 0. I check to see if that enum is of type flags. If it is, things get a little different, because flags allow you to combine different enum values together, because each enum value should be a power of 2. So that allows you to combine them together. The only reason this is going to matter is making sure that what they type in is valid for that data type, that enum value. Okay, next, after I prompt the user for input, oh, by the way here, if it's flags, it gives them an additional prompt saying separate multiple names with commas. Okay, we get the values that are legal for that enum type, and then we output each of those values. That's what the D format specifier is, followed by the name of each of the enum values. So that way in brackets you'll see if, let's say the days of the week, Sunday was a 0, so it'll be 0 within the square brackets, hyphen, and then Sunday. That's how this works. Now, I could have done this on a single output line, but I like to have the colors stand out. So the bracket here is going to be the prompt color, but the number, or the enum value number, is going to be the input color as well as the name. So it'll just look sharper. And then I ask the user for the value. Then if it is a flags enum, the one where each of the values of the enum can be a power of 2, I have to do one extra step to make sure that everything that was provided with those commas, remember that's what it asked for, separate them by commas, I have to make sure that the values are properly defined. That's an extra method which you'll find later in the code, in the private methods right here. Okay, I'm not going to step through this. It's a very complex piece of code, checking to make sure that every value they gave is a legitimate enum value. Otherwise, if it's a standard enum, like the days enum, Sunday, Monday, Tuesday, where it's 0, 1, 2, 3, 4 through 6, I can just call the standard enum is defined method, and as long as it is defined, we set done to true. If it's not done, then I ask the user to do it again. So clearly this is the most complicated read function we have in the group, but it will simplify things like creating a menu system if you want for your application. Let's continue down here. We have one more called pick list, which allows you to provide a prompt and a list, generic list of some items. As long as each of the items in the list has a toString override, then this will work just fine. So what will happen is, instead of just outputting a prompt saying please enter a value, it is going to loop through each of the values and say 0 this value, 1 this value, etc., and it'll keep stepping through until it's output all of them. Now, clearly, it can do up to 1,000, but that is completely useless in a console application because who's going to be able to scroll that much effectively? So I recommend, if you're going to pass a list to this pick list method, that it's less than 20 items. Otherwise, it becomes useless. And that pretty much wraps up all of the code within the console helpers. Now, what I'm going to do is show you how you can utilize this in your own code. The best way would be to encapsulate all of this inside libraries, and then you can just link to your DLL and you're good to go whenever you need to use this. But the easiest way, as far as getting it up and running, is to copy this entire block of code, go to your other console application, and create a new class. I'm going to call it console helpers, and just paste that code in. You'll notice here that it has a namespace of utilities. So if we're going to use it, we have to have a using statement in our other class, the program class, to utilize utilities. So all I did was add a new console helpers class and pasted the code from console helpers. If you want, you could also literally copy the file to the appropriate directory, and then you can show all files and pretend this is it. You could right click and say include in project, and that will do the same thing. Sometimes I think just creating the class like this, where you say right click, and then I'm going to add class. I'm also going to have a text helpers class, because there, believe it or not, there was yet another class I'm using in there. This one called safe trim. There's a method, word break mixed case. Those are to simplify text handling. Okay, and then I can also paste that in here, and that is also in the utilities namespace. So if I go back to program, I'm going to comment out read date time and read int. I think I did too much there. There we go. So I did the keyboard shortcut, so I can't call these methods anymore, which means read int here and read date time, all of those are invalid now. So what I have to do is come here and say using, and you'll see utilities pops up now. That is a valid namespace. And then, that's not utilities, excuse me, it's console helpers. Read int, console helpers, read int. Now if I remember correctly, it's called read date, not read date time. So we'll correct that. And now let's run it again. Please enter your name. 5, that's still working fine. Between 20 and 100, let's do 101. Try again, and notice here that the message it prints in the error also does the range to show you what range you have to do it in. Let's do 25. That's your birthday, 1, 2, 3. Okay, you enter January 2nd, 2003. Okay, but let's also look at that enum. And here's where I like to use the enum. Let's create an enum in here, and we'll call it menu options. and we will use quit equals 0. Let's say add is 1, subtract equals 2, and then multiply equals 3, and divide equals 4. So we have an enum here now with 5 values: quit, add, subtract, multiply, and divide. What I can do, first of all, look at this. I'm just doing a standard read line on that. Please enter your name. Why don't we use the console helper? Say string name is equal to console helpers read string. And then we will say please enter your name as the prompt. And min length, I guess someone could have a 1 character name, and the maximum is 10. Look at that. We simplified the code already. Okay, so let's go ahead and also take a look at reading in an enum value. So we can say enum, not enum, excuse me, menu options, and then we'll say, let's call it menu, is equal to console helpers read enum. Remember, I have to provide the data type here inside angle braces, which is a menu options. And the prompt is make a selection. And then I can do the console write line here. You entered, let's put just menu in here. And let's go ahead and run the code. So here's please enter your name. Let's do something too long. Okay. Notice here, it doesn't actually stop it from working. What did it do? It truncated it to those 10 characters. Enter a number, 5, 25. What's your birthday? 1, 2, 3. And now here's that enum one. It says make a selection. And notice here all the enum values are listed, 0, 1, 2, 3, 4, and all of the enum names. So I can do this 2 ways. I can say 1, you entered add, but watch what else you can do. I'll rerun the code, and let's just get through this real quick. 5, 25, 1, 2. I can also type in add. You entered add. So when you do the enum, it can be either by number or by name. So as you can see here, it distills a lot of the complexity of interacting with the console into some very simple methods that you can call. So we are now asking for a string, 2 ints, a date, and an enum value, and we're changing colors and outputting things, and all of that is around 20 lines of code instead of one input taking 30. So I think that this console helpers class is going to assist you in your programming endeavors because it takes a lot of the pain out of console interaction. You can feel free to use this code however you wish and to enhance it to your liking to handle even more data types than what it already supplies.